Hi guys, welcome back to our YouTube channel. Today we're going to dive in the world of file system, where the hidden architecture and organize the data of your computer. Today we're going to tackle what is file system, what is file system architecture, how the file system works, and its types. Ever wonder what's really going on behind the scene when you save a file or open a program? In this video, we'll unravel a mystery of file system, exploring how they organize your data, the different types available, and why understanding them is essential for anyone who uses a computer. Get ready for a fascinating journey into the heart of your digital storage.
File system. A file system is a logical and physical system for organizing, managing, and accessing the files and directories on a device's solid-state drive, or SSD, hard disk drive, or HDD, or other medium. Without a file system, the operating system, or OS, would see only large chunks of data without any way to distinguish one file from the next. As data capacities increase, the efficient organization and accessibility of individual files become even more important in data storage. Digital file systems are named for and modeled after the paper-based file despite their shared roots. However, file systems can differ significantly between operating systems such as Microsoft Windows, Mac OS, or Linux. On the other hand, an OS can support multiple file systems despite their differences. A file system can also be used across multiple platforms. Some file systems are designed for specific applications, including distributed file system, disk-based file system, and special-purpose file system.
File system architecture. File systems handle both physical and logical operation associated with managing files, although they take different approaches to storing file data. They commonly separate metadata from the file's content data. They also store a small amount of other data types, which are used for maintaining the file system and facilitating file access. A file system divides partition into blocks, and their size depends on the file system. Most of the blocks are used for the file's content data. The remaining blocks are divided between the file's metadata and the file's management data. Figure 1 provides a conceptual overview how a file system in a Unix-like environment might organize the data across the individual blocks. In this case, the metadata is stored in index nodes. An inode is an indexable data structure that maintains details about the file or directory. The management data occupies the first few blocks, followed by the inode metadata, and then the content data blocks would consume most of the storage. Here's a breakdown of different block types. Superblock. The block contains information about the file system itself, acting as its own metadata repository. For example, the superblock might include details about the file system type, total number of blocks, number of inodes, or other components. Data block bitmap. The block contains a simple bitmap that indicates which data blocks are used or unused. A value of 1 indicates the block is used, and a value of 0 indicates it is unused. Inode bitmap. The block contains a simple bitmap that indicates which nodes are used or unused. A value of 1 indicates the inodes is used, and a value of 0 indicates it is unused. Inodes. The file system maintains an inode for each directory. The inodes is identified by unique number and includes the metadata for associated files or directory. It also includes the address of data blocks that contains the file's content. In this way, the inode can be used to quickly locate the file. Content data blocks. All file content is stored in the data blocks. These blocks represent most of the occupied blocks of the file. The figures show only a portion of the content data blocks. File system metadata. To store and retrieve files and to provide user with information about their file. File systems do not necessarily track the same types of metadata, but they usually maintain the following information. Date and time created. Date and time modified. Date and time last access. File owner. Access permissions. File size including size on disk. Attributes as read and only or hidden. Location in directory hierarchy.
System access. File systems can restrict read and write access to a particular user or group of users, along with controlling who can modify or read files. Restricting access controls and limits data modification. File and directory permissions can be used to control who has access to specific resources and what level of access they have. This approach is useful in preventing access by internal users, but it is not as effective against outside intruders. Encrypting files can also prevent user access, but it is focused more on protecting system from outside attacks. An encryption key is applied to an encrypted text to encrypt it. The photo shows, the user can have access a key that can encrypt the message and use the cryptographic algorithm to encrypt the plain text into different letters, symbols, and numbers. The key can also be used to decrypt the encrypted text. Only users who have the key can decrypt the file. With encryption, the file system does not need to know the encryption key to manage the data effectively.
File systems definition evolves. While previously referring to physical files, the term file system has been used to refer to digital files since early 1961. By 1964, it had entered general use to refer to computerized file systems. The term of file system can also refer to the part of the OS or add-on program that supports a file system. Example of such add-on file system include the Network File System or NFS and the Andrew File System. Andrew File System is a global system that allows access to files from Mac, Windows, or Linux computers. It is similar to cloud-based storage, however, the data is stored locally. Carnegie Mellon University.
How file systems work. A file system stores and organizes data. It can talk of as a type of index for all the data contained in storage device. In addition to SSDs and HDDs, file systems are used for optical disks, flash drives, and magnetic tape. File systems specify conventions for naming files, including the maximum number of characters in a name, which characters can be used, and, in some systems, how long the file name extensions can be. In many file systems, file names are not case sensitive, along with the file's content data. A file system maintains metadata about the files along with other information. The metadata might include details such as the file size, creation date, or location in the directory. Most file systems organize files in a directory hierarchy with a file's location described by its paths. Within the directory structure, the directories folders in Windows are organized into an inverted hierarchical tree structure. With the root directory at the top, each file is placed in a directory or subdirectory at desired location within the tree structure.
Imagine your computer as a giant library filled with all sorts of digital information. A file system is the librarian of this library, making sure everything is organized and easy to find. And in a nutshell, the file system is the backbone of your computer storage. It helps you keep your digital world organized and accessible.